Jang Tiani. Oh, yeah.
Okay, hello everyone. I'm Tian Yi. I'm a master student at Louisiana State University. This is my third semester here, and my topic today is a conversation analysis framework using speech recognition and naive bias classification for construction process monitoring. At first, I want to advertise some of my paper. Um, we submitted three papers in this conference, and one is about sound classification, and one is this one, and another one is about the data federation, which is related to the first two. We want to make some um, make some contribution about the sharing of the data. So don't hesitate to cite it if you are interested. You can always find your text. Okay, let's go back to our topic today. Um, so the construction site has been always suffering from the lack of real-time monitoring system and information sharing and data collection technology. So with the development of information technology, we currently the construction site is also seeking for this kind of method. The computer vision based and sensor based has been widely developed, and however, the sound based is still being overlooked. So what we want to do is implement the sound recognition and text classification technology at the construction site. The speech recognition technology has been widely developed and implemented, so it can be used to monitor the construction operations to for us to figure out what's going on and measure the productivity of the construction site. So why we need to use the two-way radio monitor compared to vision-based and vision-based, the audio-based has lower data processing weight and it doesn't require any level of illumination. Um, and it can convey vital information because we can record what what are the workers are talking about and figure out what's going on at the construction site. Let the domain manager know what is happening and make the data-driven decisions. Um, this is our research approach and methodology. Um, our objective is we want to build a framework that can convey the speech, the conversations happening at the construction sites via the two-way radio and transcribe them into text and using some machine learning algorithms to classify them into different topics in order to achieve the monitoring goals to know what is happening at the construction site. So first, we need a speech recognition library or technology. What we implement is we employ the Synthetix library in Python to do the speech recognition work. This library is based on hidden marker models. Our another paper detailedly discussed about hidden marker models, but in this paper is not our focus. So I will just talk about the next step, text classification. We use naive bias classifier to classify the text. However, because this classifier is pretty naive based on the name, so we faced lots of problems, and we proposed some modification of this algorithm so we can achieve a better goal. The framework is shown as follows. We have labeled training data set, and we lemnitize and remove the stoppers. And so as I talked before, the classifier has lots of issues, so we extracted the keywords from the training set and testing set. We use actually a keyword-based naive Bayes classification. This is just come to my idea, and because this is the work I did in my first semester of the study, so I didn't really read many papers and don't know other method. I just generate this keyword based, and it works fine, and I just use this method. So now I look back to the previous work. Okay, there's lots of things and aspects I can improve. I feel that might be the process of study. So we collected the 12 categories of data, and it's like 2,700 of words, and it contains 12 categories like concrete grinding, excavator. We collected them on the web and some YouTube video. We transcribed the YouTube videos, so we get this data set. However, I didn't have the ability to process that large size of data at that time, but now I can process that. So in this paper, I just extracted 3 work types and use the really easy naive Bayes classifier to classify the text. But now we are using the whole data set and using machine learning algorithm neural network to classify the text and get much better and convincing result. And we don't need to extract keywords anymore. We can just classify and which is faster. So the naive Bayes classifier is just we use the probability of a document, can be the projection of the probability of a word, and we can get the result. So for this data set, the accuracy is pretty acceptable. And we saved the data because we collected sound data and text data, and we saved them on the DSpace, which is a pretty wide used data share platform. And the benefits, it can imagine that we just sit in the office and we can know what the workers are talking about, and we can know the process. And this paper is actually I thought that nobody really explores this area. This paper shows the possibility of that. We can sit on the. We don't need to go to manually collect the data or let the workers report the data every day. So we need to take advantage of the computer. So we can improve labor efficiency, make more accurate decision making, and monitor the operation activities. So our future research, as I talked about, we are using neural networks and processing for larger size of data, and this data collection is pretty tedious and work. So it takes lots of time. So thank you. That's my presentation, and any questions I would like to answer.
Thank you very much for that presentation. So it's always a challenge to categorize words, even if you have labels to fix them, because of sometimes the ambiguity or the way that the text is presented, it's challenging to run through the algorithm. Yeah. So I just wanted for you to provide us some insight of how you did pre-processing of the text, so that you could input it in the algorithm and present something reasonable.
We first lemnitize the text script. Like if you have the ing format and the current format, we just combine them into one. So another way is we remove the stop words. There's a stop words list. So we remove the stop words like of, a. These are nonsense words. And for this algorithm, because it's not really good at it, so we extract the keywords. There's a keyword extraction library. There's a paper talking about that. It's based on not only the frequency of the word, but also the structure of the sentence to extract the keywords. Yeah, that's the how to pre-process the text.
Yeah. So, so all the keywords, are they in English or Spanish and English?
Sorry, are they in English or
And Spanish.
in Spanish?
Yeah.
Ah.
Because in Southwest, there are most of the
Yeah.
workers are Spanish speaking people.
Yeah, that's a problem. Yeah.
So, do you incorporate any Spanish words or is it just English for now?
Yeah, now it's English. Because I don't know Spanish. Yeah, when I visit construction site, yeah, all workers speak Spanish. Yeah, that's a problem.
Other questions? Okay, thank you.
Thank you.